Welcome to the world of captivating stories. Here, we explore the past to help you drift off to sleep while gaining new knowledge. Don't forget to support us because by the end of our tale, you'll slip into sweet dreams. Close your eyes and we'll begin. About 4 billion years ago, something incredible happened in the molten primordial ocean of our Earth, the birth of life. From tiny bacteria barely visible to the naked eye, beings capable of pondering their existence emerged after billions of years, questioning and altering the world around them. Homo sapiens, our species, appeared around 300,000 years ago. But why us? Why did Homo sapiens survive the ice ages, outlast other ancient humans, and come to dominate the planet? Today we'll embark on an exciting journey through eras filled with dramatic events and astonishing transformations to uncover the mystery of our origins. Approximately 13.8 billion years ago, a phenomenon known as the Big Bang occurred. At that moment, all the matter that later formed the universe was compressed into an incredibly dense and hot state called a singularity. Within moments of this event, the universe began to expand and cool rapidly, allowing the first elementary particles, protons, neutrons, and electrons, to form. After a few minutes, the simplest atoms emerged, primarily hydrogen and helium. About 200 million years later, the first stars formed from giant gas clouds under the influence of gravity. These early stars were extremely massive, composed almost entirely of hydrogen and helium, and existed for a relatively short time. At the end of their life cycles, they exploded as supernovae, ejecting the first heavy elements into space, which later became the building blocks for forming planetary systems, including our solar system. Earth formed around 4 billion years ago from a cloud of interstellar material orbiting a young sun. Initially, the planet was a molten sphere covered in oceans of magma and surrounded by a dense atmosphere of steam, carbon dioxide, methane, ammonia, and hydrogen sulfide. Frequent collisions with comets and asteroids gradually brought water and organic compounds to the surface of our planet. About 4.3 billion years ago, Earth cooled, and water vapor in the atmosphere began to condense, forming the first oceans. It was in these oceans that one of the most significant events in the planet's history occurred, the emergence of life. Modern scientists believe that life arose from complex chemical reactions between organic compounds dissolved in water. Energy sources for these reactions may have included lightning, solar ultraviolet radiation, and heat from deep-sea hydrothermal vents, which are volcanic systems on the ancient ocean floor. The first living organisms were microscopic, single-celled forms without nuclei, known as prokaryotes. They include bacteria and archaea, capable of surviving in extreme conditions. The oldest fossils of such organisms found in rocks in Australia and Greenland date back about 3.7 billion years. However, there are more contentious finds dating up to 4.1 billion years in Canada and Greenland, whose classification as living organisms remains debated in the scientific community. About 2.5 billion years ago, a crucial turning point occurred. The first cyanobacteria emerged, possessing the ability to photosynthesize. These organisms began to release oxygen as a byproduct of their metabolism. The mass accumulation of oxygen in the atmosphere, known as the oxygen catastrophe, started around 2.4 billion years ago. This process occurred slowly, lasting hundreds of millions of years, gradually enriching Earth's atmosphere with oxygen and creating conditions for the evolution of more complex life forms. Approximately 540 million years ago, the Cambrian event took place, one of the most significant and mysterious occurrences in Earth's history, known as the Cambrian Explosion of life. During this period, over a relatively short span of around 30 million years, a vast array of diverse life forms emerged on our planet, many of which developed hard skeletons and protective shells for the first time. Before the Cambrian, life on Earth mainly consisted of single-celled organisms, simple algae, and primitive multicellular forms like sponges and jellyfish. However, the Cambrians saw a real explosion of diversity and complexity among the organisms that populated ancient oceans. During this period, almost all major types of animals known today emerged: arthropods, mollusks, echinoderms, the first vertebrate ancestors, and many others. One of the most striking symbols of the Cambrian explosion is the famous fauna, whose remains were found in Canada. These remarkable fossils were preserved with incredible detail, allowing scientists to glimpse the world of living beings that inhabited ancient seas. Among them were truly bizarre creatures, such as the predatory Anomalocaris, reaching lengths of about 1 meter and resembling a giant shrimp, with unique grasping appendages used to capture prey. The Hallucigenia, a worm-like creature with long protective spikes on top and thin legs below, also deserves mention. Initially, scientists struggled to determine how this organism was oriented and often depicted it upside down, but later the correct position of its body was established. Another fascinating creature was Opabinia, a marine dweller with 5 eyes and a long, flexible trunk. The reasons for the rapid emergence of new life forms continue to be debated by scientists. Among the most common hypotheses are changes in the chemical composition of the oceans and the achievement of a critical oxygen level. Although oxygen levels began to rise long before the Cambrian, it was during this period that its concentration first reached levels necessary for the development of complex multicellular animals. Another significant factor is believed to be the emergence of active predation, which triggered a sort of arms race among animals, compelling them to develop protective shells and more complex body structures. The Cambrian explosion laid the foundation for further evolutionary development of multicellular life on Earth. Although many of the animals that appeared during this period later went extinct, it was then that key organizational types were established, from which almost all modern animals descended, including our distant ancestors. About 375 million years ago, events occurred that forever changed the course of life history on our planet. During this time, separate groups of fish began gradually leaving their familiar waters to explore land. This process didn't happen instantaneously. The transition from a fully aquatic lifestyle to land dwelling took millions of years and numerous gradual changes. The first vertebrates to conquer the land were early tetrapods, 4-legged animals. Their ancestors were ancient lobe-finned fish, like Tiktaalik, which already had powerful fins resembling limbs, enabling them to push off the bottom. Animals began to emerge from water bodies and could temporarily stay on land, moving between various water sources. Over time, their fins transformed into limbs, and primitive lungs became increasingly efficient for breathing air. These early creatures laid the groundwork for the evolution of true terrestrial vertebrates. About 320 million years ago, a new significant group emerged from the first tetrapods, amniotes. Their major achievement was the amniotic egg, which had a tough shell and was filled with fluid. This innovation allowed animals to fully abandon aquatic environments for reproduction and adapt to a range of terrestrial ecosystems. Amniotes include modern reptiles, birds, and mammals. The age of reptiles began after the Permian-Triassic extinction, which occurred around 252 million years ago, wiping out about 95% of all species on Earth. In the following 20 million years, reptiles like therapsids, mammal-like reptiles, and archosaurs, ancestors of dinosaurs and crocodiles, dominated land. The first dinosaurs appeared only about 230 million years ago in the Triassic period. Over the next 150 million years, they became the leading representatives of the animal kingdom, showcasing incredible diversity in form and size. They included massive herbivorous sauropods like Diplodocus and Brachiosaurus, as well as carnivorous theropods like the famous Tyrannosaurus and Allosaurus, along with many other fascinating creatures. While most dinosaurs went extinct, one group continues to thrive today as direct descendants of these beings. Modern birds evolved from small feathered theropods and, scientifically speaking, are living dinosaurs. However, other creatures also existed during the reign of dinosaurs, waiting to take their place. The first mammals appeared about 200 million years ago and were small, about the size of today's mice or shrews. They coexisted with dinosaurs for a long time, mostly living nocturnally and avoiding large predators. 66 million years ago, a new disaster struck Earth. The impact of an asteroid about 15 kilometers wide in what is now Mexico, near the Yucatan Peninsula. The explosion had catastrophic consequences: tsunamis, fires, and a global nuclear winter lasting several years, blocking sunlight and sharply lowering temperatures. This event, known as the Paleogene extinction, proved fatal for most dinosaurs. Nearly all dinosaur species, except for birds, perished, opening the door for small, humble mammals. With the disappearance of large predators and dominant herbivores, ecological niches became available, which mammals quickly filled. A tumultuous period of evolution began. They rapidly grew in size, diversity, and numbers, occupying all ecosystems from hot tropics to cold plains. Interestingly, despite the advantages that life on land offered vertebrates, not all animals were content. Some tetrapod groups evolved to return to water. About 50 million years ago, modern whales and dolphins evolved from terrestrial ancestors whose forelimbs had adapted back into flippers. About 65 million years ago, as Earth began to recover from the global catastrophe, the age of mammals flourished. During this time, the newly available ecological niches were filled by various animal species, including the first primates, the ancestors of modern monkeys and humans. The first primates emerged about 55 million years ago at the beginning of the Eocene epoch. At that time, the climate was significantly warmer and wetter than today. Vast areas of the planet were covered in dense tropical forests, and the average temperature was about 14 degrees higher. This warm, humid climate created ideal conditions for the growth of trees, vines, shrubs, and diverse plants, forming multi-layered ecosystems. It was in these tropical forests, among the branches and foliage, that the first small animals, about the size of today's squirrels or small monkeys, appeared. These early primates adapted to a tree-dwelling lifestyle, with flexible limbs and opposable thumbs for securely grasping branches, along with long tails for added stability while moving through trees. Their eyes faced forward, allowing them to accurately judge distances when jumping from branch to branch. The first primates fed on fruits, flowers, leaves, and the abundant insects of these forests. Gradually, around 30 million years ago, the planet's climate began to change. Temperatures fell and rainfall decreased, leading to a reduction in tropical forests and an expansion of open landscapes like savannas and scrublands. These changes particularly affected Africa, where the first primates started adapting to new conditions. About 20 million years ago, a unique group of primates called hominoids or apes emerged in the dense, humid forests of Africa. These creatures were closest to the evolutionary lines that would eventually lead to humans. One of the most notable was Proconsul, found in what is now Eastern Africa. Proconsul was of medium size, measuring about 1 meter in length and weighing between 15 and 40 kilograms. It resembled a mixture of modern monkeys and apes, like chimpanzees. Proconsul lacked a tail, bringing it closer to modern apes. Its limbs were long and strong, allowing confident movement among branches. Proconsul's skull had pronounced jaws with large teeth suitable for a varied diet that included fruits, leaves, and possibly small animals. Another significant species was Dryopithecus, which lived about 14 to 9 million years ago in Africa and Eurasia. This animal was larger than Proconsul, weighing between 40 and 50 kilograms. Dryopithecus already resembled modern apes due to its more robust build. Its limbs were well adapted for vertical climbing and movement among trees, linking it with modern great apes. Its teeth and jaws were powerful, suited to chewing tough plant material typical of humid forests. The living conditions in Africa's tropical forests at that time were ideal for the development and thriving of early ape-like primates. The dense canopies provided abundant food and protection from large terrestrial predators, while the stable, warm and humid climate fostered high populations and species diversity. Gigantopithecus represented the largest of all known apes in Earth's history. Current research suggests these beings appeared much earlier than previously thought, around 8 million years ago. They reached their peak diversity about 2 million years ago, predominantly inhabiting forested regions of South and Southeast Asia. The size of Gigantopithecus was astonishing. Standing on their hind limbs, they could reach up to 3 meters, with adult individuals weighing between 400 and 600 kilograms. This made them significantly larger than modern gorillas and all other known primates. Externally, Gigantopithecus resembled gorillas, but had a more massive build. Based on the remains found, their jaws were powerful and their molars. The enormous teeth were perfect for chewing tough plant material like bamboo, leaves, and shoots. Massive teeth, much larger than human ones, provide key insights for researchers, as almost all known finds consist of teeth and jaw fragments. No complete skeletons have been discovered yet, adding to the mystery surrounding these creatures. Gigantopithecus predominantly moved on all fours, similar to modern gorillas. While they occasionally stood on their hind legs to reach high branches for fruits or leaves, this behavior was more of an exception than a rule. These gigantic apes inhabited wet tropical and subtropical forests, where they easily found food and shelter from predators. Judging by their jaw and tooth structure, they were strictly herbivorous and preferred fibrous plants. Gigantopithecus coexisted with several species of ancient hominids, including early representatives of the genus that also lived in Asia. Likely there were no direct conflicts, since they occupied different ecological niches and had varying dietary preferences. Hominids were more omnivorous and used stone tools for hunting and food processing, whereas Gigantopithecus specialized solely on a plant-based diet. However, about 100,000 years ago, Gigantopithecus went extinct. Scientists still debate the causes of this extinction. The most probable factor is climate change, leading to reduced forest areas essential for these primates. The loss of their habitat and food scarcity proved fatal for Gigantopithecus. Other factors might include competition with other animals, including hominids that more effectively adapted to new territories and resources, although this aspect isn't considered primary. About 7 million years ago, ancient hominids faced significant changes. The Earth's climate gradually became colder and drier due to global geological processes like mountain uplift and shifts in ocean currents. This led to a substantial decline in dense tropical forests and an expansion of open spaces like savannas and scrublands. The thick forests, which had been home to our tree-dwelling ancestors for millions of years, began to give way to wide plains with grass and sparse trees. These changes greatly impacted ancient hominids, our ancestors. While they once spent nearly all their time in trees, finding food and shelter from predators, they now had to adapt to new conditions. Open savannas could no longer provide reliable protection like the dense tree canopies, forcing animals to move on the ground in search of food, water, and shelter. It was in these new conditions that our ancestors gradually began to rise to 2 feet. The earliest evidence of bipedalism relates to ancient species like Sahelanthropus and Ororin, which lived around 6 to 7 million years ago. Their bipedalism wasn't as pronounced as in later representatives of our genus, but anatomical adaptations for an upright position began to form. The transition to bipedalism didn't happen for a single reason, but resulted from several factors simultaneously, and scientists still actively discuss various theories. One of the main theories suggests improved visibility in open savannas, allowing ancient hominids to spot predators and prey early. Another important hypothesis relates to energy efficiency when moving long distances across open areas. Thermoregulation might have also played a significant role. Standing upright reduced sun exposure, which was particularly beneficial in a hot climate. Some researchers propose theories about the advantages of carrying food, ease of movement in shallow waters, and opportunities for social interaction using free hands. Likely, bipedalism emerged as a result of a combination of all these factors. Freeing the forelimbs allowed hands to carry food, infants, and various objects, significantly increasing the chances of survival and exploration of new territories. The ability to create and actively use stone tools appeared much later than the first signs of bipedalism. The earliest reliable evidence of such tool use dates back to about 260,000 years ago, within what's known as the Oldowan culture. The transition to bipedalism wasn't instantaneous. It was a gradual process that took hundreds of thousands, possibly millions of years. The first hominids to begin walking on two legs could still move on all fours, especially when climbing trees or in situations requiring speed and agility. However, over time, anatomical changes became more noticeable and irreversible. The shape of the pelvis, the position of the spine, and the structure of the lower limbs gradually adapted to constant movement on two legs. About 5 million years ago, early Ardipithecus emerged, creatures that significantly resembled modern humans. Some of the most famous representatives of this group were Ardipithecus and Australopithecus. Ardipithecus lived around 4.5 million years ago in East Africa. The most well-known representative of this genus is Ardipithecus ramidus, nicknamed Ardi. These beings stood approximately 120 centimeters tall and weighed around 50 kilos. They exhibited traits of both modern apes and early humans, showcasing features characteristic of both groups. Their brains were relatively small, about 350 cubic centimeters, roughly 3 times smaller than the modern human brain. Ardipithecus could stand and walk confidently on two legs, although they retained anatomical traits indicating they still spent considerable time in trees. One of the most remarkable features of these ancient beings was their unusual foot structure, the big toe angled under, resembling the modern big toe of tree-dwelling apes, allowing them to grasp branches. This trait indicated they had adaptations for both arboreal life and movement on the ground. Although they could walk on two legs, their gait was less stable compared to later Australopithecus. Their arms were long and strong, indicating their capability to climb trees effectively and grip branches tightly. Australopithecus appeared later, roughly between 4 and 1 million years ago, and were more advanced human precursors. The most famous example came from the discovery of Lucy, a female who lived about 3.1 million years ago. Australopithecus stood about 130 centimeters tall and weighed between 30 to 50 kilos. They had robust builds, with wide hips and strong legs, allowing them to walk more confidently on 2 feet. Their brain volume was larger than Ardipithecus, but still half that of modern humans. Australopithecus primarily led a terrestrial lifestyle, although they occasionally climbed trees for rest or shelter from predators. Their diet primarily consisted of plant materials, fruits, seeds, roots, and leaves. However, they were omnivorous and could occasionally consume small animals and insects when possible. Australopithecines had large, durable teeth, which allowed them to effectively process tough vegetation. Life for ancient hominids was full of challenges. In open savannas, various predators such as saber-toothed cats and large hyenas threatened them. To survive, they formed small social groups, caring for one another, defending themselves, and hunting together. This lifestyle fostered the development of social skills and communication, which in turn boosted their intelligence. These species marked significant steps in human evolution. Australopithecines are considered important ancestors of the Homo genus, although details of their evolutionary link are still being studied. About 2,500,000 years ago, a new species of hominids emerged in Africa, marking a crucial step toward modern humans. This species was Homo habilis, the first representative of our genus. It began a new era in human evolution, characterized by stone tools and lifestyle changes. Homo habilis stood between 100 and 140 centimeters tall and weighed between 30 and 50 kilograms. Externally, they resembled Australopithecines but were anatomically more advanced. One noticeable difference was the increase in brain volume, which measured about 700 cubic centimeters, 1.5 times larger than that of Australopithecines. This marked an important step toward enhancing cognitive abilities. The most significant achievement of Homo habilis was the creation and use of the first stone tools. Archaeologists classify these tools under the Oldowan culture, named after the Olduvai Gorge in East Africa, where the first specimens were found. The tools were simple stone flakes created by striking one stone against another. Despite their primitive nature, they were highly effective. With these tools, ancient hominids could butcher animal carcasses, crush bones to extract marrow, and process plant food. The diet of Homo habilis included not only vegetation, but also meat from animals hunted or scavenged. They primarily hunted small to medium-sized mammals, such as antelopes and rabbits, as well as various birds and reptiles. They had to compete for food with other hominids, including paranthropines and large herbivorous Australopithecines, as well as various predators like hyenas and saber-toothed cats. Life in the savannah was tough and dangerous, which encouraged the development of group living, social cooperation, and tool-making, all crucial for survival. Living in groups of 10 to 20 individuals, Homo habilis effectively defended themselves against predators and successfully searched for food. Their social structure included early forms of division of labor. Some group members searched for suitable stones for tools, others butchered animal carcasses, while some guarded the group or gathered plant food and water. Thus, early humans utilized available resources and reduced risks associated with food gathering. During this time, Homo habilis did not have the ability to create or maintain fire, making nights a period of heightened danger. In darkness, they sought shelter among large rock formations, avoiding encounters with nocturnal predators. However, hominid evolution continued, and about 1,900,000 years ago, a newer, more advanced species appeared in Africa, Homo erectus. This species became the next significant step toward modern humans, ushering in a new era when our ancestors began actively exploring new territories and continents. Homo erectus differed significantly from its predecessors in height and build. The average adult stood about 168 to 180 centimeters tall, making them noticeably taller and leaner. Weighing between 50 and 70 kilograms, their body proportions became more similar to modern humans. Brain volume also increased, ranging from 800 to 1,000 cubic centimeters. One of Homo erectus's main achievements was mastering fire. Approximately 1 million years ago, these ancient people learned not only to use fire created by natural events, but also to maintain it and eventually create it themselves. This discovery drastically changed their lifestyle. Fire provided warmth, protection from predators, and the ability to cook food. Cooked food became easier to digest and absorb, allowing for more energy and nutrients. This in turn supported brain growth and bodily development. Homo erectus also became the first true travelers. Around 1,800,000 years ago, they began leaving Africa and settling in other parts of the world. The large-scale migration of hominids from Africa marked the start of an era of global human settlement. The first new lands explored by Homo erectus included regions of modern Georgia, China, and Southeast Asia. The earliest finds confirming their presence outside Africa were discovered in the Manisi, dating back approximately 1,800,000 years. Later, upright humans reached China and the Indonesian islands and then spread to other regions of Eurasia, including present-day Europe. These long and complex journeys through diverse climatic zones were made possible by high adaptability, the ability to create fire, use primitive tools, and develop social skills. People moved in small groups, closely cooperating to gather food, build shelters, and protect themselves from dangers. Homo erectus became the first to create relatively complex stone tools associated with the Acheulean culture. Their well-crafted hand axes and pointed tools served as versatile implements for hunting, butchering, gathering food, and constructing shelters. These tools allowed for more efficient food gathering and adaptation to new, often harsh living conditions around the world. However, the process of global settlement wasn't without challenges. People faced new types of predators and unfavorable climatic conditions, especially in the colder regions of Eurasia. In Europe, they coexisted with large predators, such as cave bears and lions, and hunted large herbivores, including deer, bison, and even elephants, to secure food. The ability to maintain and use fire for protection and warmth became a critical aspect of survival in these conditions. About 2,500,000 years ago, Earth entered a period of drastic climate changes known as the Pleistocene. The onset of ice ages was triggered by several natural factors, primarily cycles related to changes in Earth's orbit and axial tilt. These cycles, named after the Serbian scientist who first studied their impact on climate, led to fluctuations in solar energy reaching different regions of the planet in various seasons, causing global cooling and warming. Combined with changes in solar activity and oceanic currents driven by tectonic plate movements, these processes significantly affected the climate. As a result, the climate on Earth, temperatures dropped dramatically, and the planet entered an era of prolonged glacial periods, interspersed with relatively brief thaws. Extensive areas in North America, Europe, and Asia became covered with thick ice, while sea levels fell significantly due to the freezing of large volumes of water. These abrupt climate changes greatly impacted flora and fauna. Vast forests and lush jungles gave way to cold steppes and tundras dominated by tough grasses and shrubs. This shift in landscape altered the animal kingdom, with warm, loving species replaced by animals well adapted to harsh conditions, like mammoths, woolly rhinos, and giant deer. In these circumstances, ancient hominids faced new challenges requiring significant adaptation. Around 800,000 years ago, a new species of ancient humans, known as Heidelberg man, emerged in Europe and Africa. This species looked quite similar to modern humans. Adults reached heights of about 170 cm, had robust builds, and possessed brains nearly as large as those of contemporary humans. Their faces were large and massive, featuring pronounced brow ridges and wide nostrils. However, compared to earlier species, their features were less coarse. One key characteristic of Heidelberg man was the ability to effectively hunt large animals. Using complex stone tools, they hunted large herbivores like bison and horses, as well as elephants and rhinos. This hunting required not only physical strength, but also coordinated collective actions, indicating a high degree of social organization. Besides hunting, they gathered berries, nuts, and plant roots, adding essential nutrients to their diets. Early signs of organized permanent settlements near water sources and food supplies began to appear. To protect themselves from the cold and predators, Heidelberg people built simple shelters using tree branches, animal bones, and hides. Archaeological findings show that some groups regularly returned to the same sites, signaling the start of sedentary traditions. One of their key skills involved using fire. They built fires for cooking, warmth, and protection, giving them a significant advantage in surviving in northern regions of Europe where life without fire was extremely challenging. Heidelberg man is considered an important link between early Homo species and later varieties like Neanderthals and modern humans. About 400,000 years ago, a new species of ancient humans, Neanderthals, arose in Europe, becoming one of our most well-known ancestors. Initially, Neanderthals inhabited Europe, soon spreading to western territories of Asia. The earliest finds related to early forms of Neanderthals date back approximately 350,000 years. However, typical Neanderthals, with their characteristic anatomical features, formed a bit later, around 200,000 years ago. These ancient hominids adapted remarkably well to the harsh conditions of the glacial periods, becoming one of the most advanced human forms that existed before modern humans appeared. Neanderthals had strong muscular builds, typically reaching heights of around 160 centimeters and weighing up to 80 kilograms or more. They had robust bodies, broad chests, and massive skulls with pronounced brow ridges and protruding noses, helping them retain heat and survive in cold climates. Neanderthal brains were quite large, even slightly larger than those of modern humans. However, it's important to note that brain size isn't always an indicator of intelligence. Neanderthals had larger brains, which might suggest a higher level of intelligence compared to modern humans. Yet, their brain structure differed, possibly influencing their perception and behavior. Despite this, their brain development manifested in culture and lifestyle. Neanderthal culture exhibited remarkable diversity and complexity. They actively used advanced stone tools belonging to the Mousterian culture, which were more specialized than their ancestors' tools. Neanderthals crafted spear points, knives, scrapers for processing hides, chisels and other multifunctional tools, selecting quality stones like flint, quartzite, and obsidian, and meticulously shaping them for desired forms and sharpness. One of their outstanding traits was hunting efficiency. Neanderthals were masters of collective hunting, working together to drive and take down large animals like mammoths, woolly rhinos, and cave bears. Successfully executing such tasks required not just physical skills and strength, but also teamwork, planning, and strategy. They used spears and possibly throwing weapons, significantly enhancing their effectiveness and safety. Moreover, a unique aspect of their culture was their burial practices. Archaeological finds confirm that Neanderthals buried their dead, digging graves and placing bodies in specific poses, sometimes using red ochre, which may symbolize life or rebirth. In some cases, graves contained flowers and objects that likely held symbolic significance. This suggests a high level of spiritual development, an awareness of mortality, and the ability to contemplate an afterlife. Neanderthals also displayed a high level of social organization and mutual aid. Findings indicate that they cared for sick, injured, and elderly community members, providing support even when those individuals couldn't hunt or care for themselves. This required developed emotional and social intelligence, empathy, and an understanding of the importance of community bonds. However, around 40,000 years ago, Neanderthals began to gradually disappear, and by 35,000 years ago, the species was completely extinct. The reasons for their disappearance remain a topic of scientific debate. One popular hypothesis suggests that a complex set of factors led to their extinction. First, about 50,000 years ago, representatives of our species began spreading across Europe and Asia, possessing several advantages like more advanced technologies, varied hunting methods, and complex social structures. This placed Neanderthals in challenging competitive conditions for resources and territories. Climate change at the end of the last glacial period could have also played a role, reducing animal populations and migrations, complicating hunting and survival conditions. Genetic studies show that Neanderthals and modern humans interacted, leading to gene mixing. Modern humans living outside Africa carry about 1 to 4% Neanderthal DNA, indicating that their disappearance occurred not just through extinction, but also through interbreeding with Homo sapiens. The first Homo sapiens appeared in Africa around 300,000 years ago. The oldest finds of our species were discovered in Morocco, Ethiopia, and South Africa. These findings show that our earliest ancestors possessed many traits typical of modern humans, such as a high forehead, a rounded skull, and delicate facial features, while still retaining some more archaic characteristics. Homo sapiens evolved from older African hominid species, like Homo heidelbergensis. The common ancestor of all three species existed about 800,000 years ago, with one branch leading to the first Homo sapiens and another to Neanderthals and Denisovans. Thus, Neanderthals and Denisovans are closer relatives, while Homo sapiens represent a separate evolutionary line distinguished by a unique type of thinking and capacity for abstract perception of reality. Around 100,000 years ago, Homo sapiens created complex tools, ornaments, and symbolic items like shell beads and ostrich eggs, reflecting their pursuit of beauty and the formation of early concepts of symbols and spirituality. Archaeological excavations in Africa and the Middle East have yielded numerous finds illuminating the daily lives of our ancestors. For instance, in Blombos Cave in South Africa, ancient ornaments dating back about 75,000 years were discovered, along with pieces of ochre featuring carved geometric patterns, some of the earliest evidence of abstract creativity. In Israel, at the Shukak Cave, remains of ancient Homo sapiens around 100,000 years old confirm early human migrations from Africa. Additionally, remnants of dwellings and stone tools reveal long-term adaptation to new territories. In the Koveze cave in Israel, the bodies of the deceased were carefully laid in graves, adorned with ochre and accompanied by certain items, indicating respect for the departed and the presence of developed social ties. People began using increasingly complex tools, such as arrows, needles, and musical instruments, while cave paintings became a vivid expression of our ancestors' creative abilities. Thanks to their intellectual capabilities and social cooperation, Homo sapiens adapted to various conditions. About 60,000 years ago, a second major wave of Homo sapiens migration began, covering Eurasia, Australia, and later America, ultimately leading to Homo sapiens becoming the sole human species on the planet, gradually displacing or assimilating their ancient relatives. The well-known Neanderthals and the less studied but quite mysterious Denisovans. Neanderthals were mentioned earlier. Notably, they inhabited Europe and Western Asia significantly earlier than modern humans appeared, and their interactions couldn't go unnoticed. For roughly 15,000 years, both species lived side by side, sometimes competing for resources, and sometimes interacting peacefully, and even interbreeding. These contacts resulted in modern humans descending from non-African ancestors, inheriting 1 to 4% of Neanderthal genes, reflected in our immune systems and traits like skin, hair, and other characteristics. However, Denisovans represent an even more intriguing and enigmatic research subject. The existence of this ancient group became known only recently due to remarkable finds in Denisova Cave in Altai. The first artifacts were discovered in 2008 when archaeologists found a fragment of a girl's finger bone who lived around 50,000 years ago. Analyzing her genetic material caused a real scientific shock, as it turned out to be a completely new species of humans previously unknown to science. Despite the significance of this discovery, very little is still known about Denisovans. Based on the bones and teeth found, we can assert that they bore anatomical similarities to Neanderthals, but were also significantly different genetically and likely had a shorter stature, about 150 centimeters. Genetic analysis revealed that Denisovans and Neanderthals diverged roughly 400,000 years ago, evolving in different directions and occupying various ranges. The culture of Denisovans also remains largely unstudied, although some archaeological finds suggest its extraordinary complexity and uniqueness. In Denisova Cave, not only stone tools were uncovered, but also stunning art objects and ornaments, among which the famous bracelet made of green chloritolite stands out, crafted with high skill about 50,000 years ago. The drilling technology employed in this bracelet is so complex that it requires exceptional skills and tools which no one expected to find in such ancient people. This discovery changed our perception of the cultural level of Denisovans and showed that they possessed refined skills and a sense of aesthetics. The question of how they dispersed across Asia and reached remote regions remains one of the intriguing mysteries, given that their genes have been found even in the inhabitants of Southeast Asian islands. Denisovans, or their descendants, may have used primitive watercraft to cross maritime straits. It's unclear whether direct military conflicts occurred between Homo sapiens and other human species, as direct archaeological evidence of such encounters has not yet been found. However, some indirect data suggest possible tense relations and conflicts. For instance, marks of wounds and injuries have been discovered on Neanderthal and ancient Homo sapiens bones, but it's uncertain if they resulted from interspecies encounters or intraspecies conflicts. Nonetheless, competition for limited resources, such as hunting grounds and caves, could certainly lead to aggression and localized conflicts. The interaction of Homo sapiens with Denisovans, as with Neanderthals, involved not only struggles for space and resources, but also periods of coexistence and even mixing. This was particularly active in Asia and on oceanic islands. Modern inhabitants of Australia, New Guinea, and some Pacific islands carry up to 6% Denisovan DNA in their genomes. These genes helped our ancestors adapt to new living conditions, including survival at high altitudes and acclimatization to local climates and diseases. However, despite such interactions, Denisovans disappeared around 30,000 years ago. The reasons for their extinction likely include competition with Homo sapiens for resources and territories, climate changes, and gradual absorption through interspecies mixing. Another interesting group is the so-called hobbits from the island of Flores, diminutive people known in the scientific community as Homo floresiensis. These unusual beings stand out among other ancient human representatives due to their miniature sizes. An adult individual barely exceeded 1 meter in height and rarely weighed more than 25 or 30 kilograms. Their brain volume was extremely small, around 400 cubic centimeters, comparable to that of Australopiths. Despite their modest brain size, these diminutive people displayed a high level of intelligence and successfully adapted to the challenging living conditions on the island. The remains of hobbits were first discovered by archaeologists in 2003 in the Liangbua cave on the island of Flores. The most famous discovery was the skeleton of an adult woman named Flo. Later, several more remains were found in the same area, along with stone tools, fire pit evidence, and animal remains that these ancient people hunted. This confirmed that the dwarf people weren't an accidental anomaly, but a distinct, well-adapted species that thrived on the island for tens of thousands of years. The uniqueness of the Flores people largely stems from the phenomenon of insular dwarfism, an evolutionary process where limited resources and space lead to smaller sizes in animals. Concurrently, another phenomenon was developing on the island: gigantism in some species. Alongside the tiny humans, Flores was home to giant rats the size of small dogs, enormous storks over 1.5 meters tall, and dwarf stegodons comparable in size to large bulls. Despite their small stature and limited resources, the dwarf people effectively hunted stegodons and other large animals. This hunting required high coordination, teamwork, and strategic thinking. Their diet included meat from large animals and various plants, small animals, birds, and abundant marine life along the island's coast. The hobbits could create stone tools, maintain fire, and build simple shelters. They led complex social lives, essential for survival in confined spaces, and the dangerous presence of large predators. The reasons for the dwarf people's disappearance remain unclear. It's most likely that around 50,000 years ago, this unusual species faced climate changes, resource depletion, or competition from incoming representatives of Homo sapiens. The latter possibly played a significant role in the ultimate extinction of the Flores hobbits. While many questions remain unanswered, the dwarf people of Flores have forever entered the annals of science as one of the most astonishing examples of how diverse human evolution can be under complete geographical isolation. About 12,000 years ago, the last ice age ended, leading to a significantly milder and warmer Earth climate. As glaciers melted, vast areas transformed into green plains, dense forests, and fertile lands. During this period, a crucial event in human history began, shaping the future trajectory of our civilization: the Neolithic Revolution. The shift from a hunter-gatherer lifestyle to settled existence based on agriculture and animal husbandry occurred gradually over long centuries and even millennia. This process first took place in an area known as the Fertile Crescent, encompassing modern-day Turkey, Syria, Iraq, and Israel. The transition to an agrarian way of life wasn't a sudden revelation, but the result of years of observing nature. People noticed that seeds planted in the soil sprouted and yielded new crops. Over time, they began selecting and planting the most productive varieties, such as barley, wheat, lentils, peas, flax, and various legumes. Simultaneously, people started domesticating animals, beginning with dogs, which descended from tamed wolves and became loyal companions in hunting and protection. Soon, goats, sheep, and cattle followed, providing meat, milk, wool, and other resources for tools and household items. One of the first domesticated animals was pigs, which reproduced quickly and required little care, ensuring stable food supplies. These lifestyle changes sparked a true revolution in the daily existence of ancient people. While the lives of hunter-gatherers were filled with uncertainty and constant migration in search of food, people could now build stable settlements and store food. The first permanent villages, like ancient Jericho and Çatalhöyük in Anatolia, emerged around 9,000 years ago and became centers of prosperity, crafts, and trade. Life in these communities changed dramatically. People began building sturdy homes from clay and stone, erecting granaries for food storage, and creating irrigation systems. With the emergence of food surpluses, labor specialization began. Some focused on agriculture, others on animal husbandry, while craftsmen produced pottery, leather goods, textiles, and stone tools. Traders also appeared, exchanging goods between various settlements and even distant regions. Agricultural development led to significant population growth. Now that food supplies became more stable, communities could support larger numbers of people. Groups of hunter-gatherers consisting of a few dozen individuals gave way to villages and small towns with populations in the hundreds and thousands. This concentration of people facilitated a more active exchange of ideas and technologies, giving a powerful boost to civilization's development. The archaeological discoveries at Çatalhöyük in Turkey vividly illustrate the successes of the Neolithic Revolution. Here, traces of houses built closely together without streets with entrances through roofs, were found. Inside, people created magnificent wall paintings depicting hunting scenes and animal domestication, along with symbolic images reflecting the development of religious and mythological beliefs. The found figurines of women likely served as symbols of fertility and motherhood. Customs involving horns built into house walls might have had ritual significance, but the shift to settled life also had dark sides. People first faced the spread of infectious diseases transmitted from domestic animals. Living permanently in large settlements contributed to epidemics that rarely occurred in smaller groups. Additionally, conflicts over land and resources arose, leading to the first signs of organized violence and wars. Archaeological excavations confirm cases of violent deaths, with injuries likely caused by clashes between settlements. Despite the challenges posed by the transition to agriculture, the Neolithic Revolution became a key event shaping humanity's future history. Thanks to it, the development of large cities, the creation of civilizations, and the formation of complex cultures became possible. One of the main factors that made us who we are today is our remarkable ability to create and transmit complex ideas and knowledge. Language, art, and symbolic thinking played crucial roles in this. The first signs of conscious symbolism emerged even before agriculture and the first civilizations, around 50,000 years ago. Back then, our ancestors adorned their bodies with shell necklaces and beads made from ostrich eggs. However, the true pinnacle of ancient symbolic creativity were the first cave paintings. The most famous examples of ancient art are found in the Altamira caves in Spain and Chauvet in France, with many of these images dating back around 40 recent years. On the walls, ancient people depicted hunting scenes and animal figures, as well as human figures, handprints, and mysterious abstract symbols, the meanings of which continue to spark debate among scholars. These paintings impress not only with their artistic beauty, but also with how deeply ancient people felt their surrounding world. For natural mineral pigments were used in their creations, mixed with water or animal fat. Some images were applied with fingers or simple brushes made from twigs and fur. Others were created using straws, which artists used to spray paint. Rock art wasn't just cave decoration. It likely held ritual significance and was part of complex hunting ceremonies. These drawings reflected early religious and mythological beliefs, marking a crucial step in human consciousness development. They allowed people to interpret the world through symbols and images. The emergence of the first myths and religions naturally followed this process. The complex world demanded explanations. Why do seasons change? How did people and animals come to be? What happens after death? Ancient people found answers in myths filled with images of gods and heroes. One of the oldest examples of ritual life is a temple complex estimated to be around 12,000 years old, located in modern-day Turkey. Here, massive stone pillars were discovered, adorned with bas-reliefs of animals and abstract symbols, clearly holding religious significance. This temple indicates that ancient people already had not only advanced consciousness, but also the ability to organize for constructing such intricate structures. The rise of complex myths and religions played a key role in uniting human communities. Shared beliefs and rituals strengthened internal bonds among community members, fostering a sense of unity and common identity. This eventually led to the formation of the first social institutions and cultural traditions. With the development of symbolic thinking and language, people could accumulate and pass down knowledge through generations, gradually transitioning from oral traditions to the first attempts to record information on clay tablets and stone slabs. Around 5,000 years ago, the first writing systems emerged: cuneiform in Mesopotamia and hieroglyphs in ancient Egypt. This became a significant milestone in history as we understand it today. With the advent of writing, humanity gained the ability to preserve information about its past, document laws and agreements, track agricultural products and trade, and record legends and myths. This marked the beginning of the formation of the first complex civilizations and cultures, laying the foundation for modern society. Conclusion: our remarkable journey is coming to an end. We started from the moment of the Big Bang, when all the matter and energy of the universe existed in an incredibly dense and hot state. About 13.8 billion years have passed since then. If we imagine the entire history of the universe as 1 hour, life as we know it on Earth appeared only in the last few seconds, while human civilization emerged just a moment before the end of that minute. Nonetheless, in this short span, life has traveled an astonishing path, from the simplest organisms and strange creatures of the Cambrian period to powerful dinosaurs and ancient mammals, from small ape-like beings to remarkably adaptable and creative humans. Each stage of this journey is marked by struggles, victories and defeats, astonishing discoveries, and constant change. The most amazing part of this story is that evolution never stops. It's continuing right now, within us and around us. We keep changing and evolving under the influence of environmental, cultural, and technological factors. Currently, humanity is not only subject to natural selection, but also, for the first time in its history, has the opportunity to consciously influence its own evolution. Genetics, biotechnology, and artificial intelligence present incredible possibilities, but they also impose immense responsibility for the future of our species. What will the next stage of our development be? No one can know for sure. However, one thing is clear: the extraordinary journey that began with the first living cell and led to the creation of complex civilizations and cultures will continue, opening new and exciting horizons for us. Thank you for your attention. If you enjoyed this material, don't forget to leave a positive review and subscribe to avoid missing new interesting lectures. Share your thoughts and suggestions in the comments and let us know what you'd like to hear about in future episodes. Until we meet again.